Hello and welcome back to the video series where we review the LEED Green Associate Exam Preparation Guide. So this video is about chapter 7, and that is water efficiency. So as you already know, there are 4 credits and 3 prerequisites in the water efficiency credit category. So the prerequisites are outdoor water use reduction, indoor water use reduction, building level water metering. And the credits are outdoor water use reduction, which is exactly the same as the prerequisite, but there are slightly different requirements. Then indoor water use reduction, same thing. Cooling tower water use and water metering. So let's dive deeper into the chapter. And the objectives of the chapter are to explain the importance of the EPA Act of 1992 and how it has affected water efficiency. Describe how flash and flow fixtures water usage is measured. Explain the importance of reducing indoor, outdoor, and process water use. List the strategies to reduce indoor water use. List the strategies to reduce outdoor water use. Describe the benefits of water metering and water performance management. So first and foremost, we need to understand actually why it is important to uh, uh, to conserve the water. So one approach is the water balance, which bases projected water usage on the annual amount of rainfall. And another approach is the efficiency first approach. So project teams using the efficiency first approach work to reduce water use first, and then they consider alternative water sources such as rainwater collection, water reclamation, and on-site treatment to tertiary standards. So in this credit category, we have the baseline and design cases. So a project obtains credits through its ability to reduce water below a set baseline. So the design case can be created from the baseline and the building's projected water usage, as well as the project team's goal for achieving water efficiency through the rating systems. So I would like you to pay attention to the water measurement units. So water closets and urinals are gallon per flush. Then faucets and showers are gallons per minute, and industrial uses is gallons per hour. So pay attention to that. That is critically important when we discuss the units. So the Energy Policy Act of 1992 sets the maximum flush and flow rates in buildings. Just because the daily water use calculation is required, the number of building occupants and their average daily water fixture use is also needed. So the EPA Act specifies the baseline water consumption information required to make the calculations. And it also has other standards and reference under the prerequisite and credit for indoor water use reduction in the water efficiency category. Full-time equivalent, or FTE, is used to calculate the number of occupants in a building with associated average daily water fixture use. So FTE is an occupant who is in the building for 8 hours a day, and that means 40 hours a week, and receives an FTE of 1.0, while part-time and overtime occupants have FTEs based on their hours per week divided by 40. Also, transient building occupants such as students, visitors, and customers are a different category. So there are nice charts here in the textbook. One is baseline water consumption and another one is water daily use rate. So please make sure that you back up this video with the textbook and you check those rates. Flash fixtures and flow fixtures. So flash fixtures and flow fixtures are two ways to dispense water from a building. So flash fixtures are toilets, urinals, and flow fixtures are faucets, hoses, and dishwashers. So let us discuss the increase in water efficiency. And we know that the goal of the water efficiency category is to reduce the amount of potable water used for purposes other than drinking and to treat and reclaim all gray water. So potable water, as we already know, is water that meets or exceeds the U.S. Environmental Protection Agency or EPA drinking water quality standards and is approved for human consumption by the state or local authorities having jurisdiction or AHJ. So in the LEED BD plus C rating system, there are three types of water usage: indoor, outdoor, and process water. A LEED Green Associate exam candidate must understand these three types of water usage and learn reduction strategies for each of those. So you need to remember that reducing water use and measuring or metering water use are the first and last strategies for each type of water usage. So when we talk about reducing the indoor water use, according to the EPA, about 70% of the total water used daily is used indoors. So, and that includes bathrooms, kitchens, flash and flow fixtures, and what we use for like drinking and cooking and hand washing and flushing toilets and all those beautiful things that we're surrounded by. So, the intent of the water efficiency prerequisite indoor water use reduction and water efficiency credit indoor water use reduction is to reduce indoor water use by lessening the amount of potable water used inside the building. And this can be accomplished through conservation and recycling. And LEED V4 requires a minimum of 20% reduction of the baseline for water used indoors. What can be done is efficient fixtures can be installed, and that can include the WaterSense labeled fixtures. So that is the initiative created by the EPA in 2006 to promote the use of partnerships that bring water-saving products and tips to the marketplace. So you can find that label on the water fixtures when you specify them. So ultra low flow water closets is the high or high efficiency toilet, or HET. Is a water closet that includes a pressure tank to produce a pressure assisted or vacuum assisted flush, and that reduced from 1.6 gallon per flush to 1.28 gallons per flush. Then dual flash water closets is a water closet that provides a flush option for liquid waste and one for solid waste. And I'm sure you've seen those in the public restrooms. Ultra low flow urinals is the urinal that uses a reduced amount of water to flush liquid waste. Low flow aerators, and that's for the commercial bathrooms where fixture replacement would be cost prohibitive. Low flow aerators are a low cost alternative that reduce the amount of water flow from a flow fixture. And again, there is a very nice chart where you can see low flow plumbing fixtures. Please refer to that. Waterless fixtures. So waterless urinals is one of them. Then another one is a composting toilet. and that is something that people use when they go camping in the remote sites where there is no septic tank or no sewage. Water reclamation systems, that is processing of water that was intended to go down a sanitary storm sewer. That is another water saving strategy. And here you can see the beautiful pictures of how actually that is organized, the composting toilets and waterless urinals. So please refer to those pictures. When we talk about the rainwater harvesting or rainwater collection, that is a process of collecting water from rooftops and paved or vegetated ground for reuse. And that, in general, untreated rainwater used for landscape and irrigation. But it can be used for cloth washing and other non-potable uses. It just needs to be going through the filtration. Gray water, what is that? Gray water is collected and treated, and that comes from showers, baths, lavatory sinks, and clothes washers. And that can be directed through piping into a holding tank for later reuse. So gray water may be filtered before it reaches the holding tank, after it leaves the holding tank, or both. Filter backwash and any excess flow into the tank are redirected to the building drain. But many codes and local jurisdictions actually limit the use of gray water. So always check with your local authority having jurisdiction if that is allowed at all before actually recommending that to the project. Reclaimed water. It is wastewater that sometimes requires treatment to meet the federal requirements for its intended use as non-potable water. And that can be used for the following: residential and commercial landscaping, recreational field irrigation, dust control and concrete production for construction projects, fire protection through reclaimed water hydrants, toilet and urinal flushing in commercial and industrial buildings, commercial uses such as high volume vehicle washing, window washing, and mixed water for pesticides, herbicides, and liquid fertilizers, industrial and utility cooling water and process application. Then we are switching to the prerequisite building level water metering. And that requires submeters to be permanently installed to measure total potable water usage in a building and its associated grounds. So those submeters are devices used to monitor water leaks and to measure usage. And the submeters can actually be installed on on the following systems: irrigation, indoor plumbing fixtures and fittings, domestic hot water heaters, and boilers. Reduce processed water use. So that is actually needed in such building systems as boilers and cooling towers. So if the project is a restaurant or a hotel, processed water can also refer to water used in dishwashers, cloth washers, and ice machines. So reclaimed water or closed loop water circulation systems can be used to reduce potable water use for industrial purposes. And instead of piping in potable water, closed loop systems can keep water clean and allow processed water to be reused for many cycles. So when we reduce outdoor water use, is actually all of the water that is used outside of the building. So the primary use of that outdoor water is landscape and irrigation. And sprinklers and drip irrigation are the two most popular ways to irrigate with water. So in the water efficiency category, there are several ways to reduce outdoor water use. The intent of the outdoor water use reduction credit and prerequisite is to reduce the amount of water needed for building site irrigation. So when you work with the water use strategies, you need to choose native and locally adapted species when planning landscaping. Use xeriscaping, and that is type of landscaping design that utilizes soil improvements, efficient irrigation, and native and adapted plant species to reduce water usage. And also you can select efficient irrigation technologies. So if the water is reclaimed, drip irrigation system is required. You cannot use the traditional sprinklers. Rainwater harvesting is capturing and collecting rainwater, as we already discussed, as the first step, and that is a non-potable water source for irrigation. Then installing sub-meters. Metering outdoor water use is critical to achieve gains in use reduction and cost savings. Water management efforts are being implemented at many different types of facilities across the country to deal with the growing economic, environmental, and humanitarian effects of excessive water consumption. So when we talk about the water efficiency, there are a few terms and definitions that are very important to understand the concept, and those are as follows. Aerator, a water flow constrictor attached to the tip of an indoor water faucet to limit the amount of water that flows out of it. Baseline case, a standard from which a basis of change can be measured for improvement. Black water, water from toilets and urinals that is considered under all codes to be wastewater. Some states also consider water from kitchen sinks, showers, and bathtubs to be black water. So always check with your local jurisdiction. Cooling tower, a structure that regulates air temperature in a facility by using water to absorb heat from air conditioning systems. Design case, the actual project design metrics that are compared to a baseline to show efficiency gains. Drip irrigation, water delivered at a low pressure directly to the roofs of a plant. The Energy Policy Act of 1992 requires that all toilets use no more than 1.6 gallons of water per flush, and all urinals use no more than 1.0 gallon per flush, among other requirements. And this concludes our chapter 7. I will see you in chapter 8.